What if the red sands of Mars were no longer just a distant dream, but a thriving reality? A world where humans, robots, and groundbreaking technologies come together to transform an alien planet into a second home for humanity. This isn't just a vision. It's the detailed roadmap of Mars colonization, unfolding from 2030 to the year 3000. Let's dive into this extraordinary journey. Mars, humanity's backup plan. Imagine traveling 33 million miles away from home to a new planet. Sounds like the plot of a sci-fi blockbuster, right? Well, it's closer to reality than you might think. Mars has captured the imagination of scientists, entrepreneurs, and adventurers alike. It's the next great frontier, and people are seriously wondering if our survival as a species might depend on colonizing the red planet. NASA, private companies like SpaceX, and other organizations are pouring resources into figuring out how to make this happen. While the dream is still decades away, the groundwork is being laid right now. Rovers are crawling across Mars's surface, robots are orbiting above, and research teams are breaking down the science of making Mars livable. The goal: have humans calling Mars home by the 2030s. Silicon Valley visionaries and space enthusiasts aren't just sitting on the sidelines either. They're betting big on Mars, funding bold projects and pushing the limits of what's possible. NASA's Dr. Jim Green even calls today's youth the Mars generation. There's no shortage of excitement or debates about what this means for humanity. Is Mars our escape hatch in case things go sideways on Earth? NASA's bold missions to explore Mars. Did you know NASA has been sending missions to Mars for decades, uncovering secrets about its atmosphere, surface, and potential for life? First up is ExoMars, a collaboration with the European Space Agency. This mission isn't just about rocks and dust, it's searching for signs of life. NASA contributed an astrobiology instrument called the Mars Organic Molecular Analyzer, which is designed to detect organic molecules. Could it prove that Mars once hosted life? That's the big question. Then there's MAVEN, the Mars Atmosphere and Volatile Evolution mission. Launched in 2013, MAVEN is studying Mars' upper atmosphere and its interaction with the Sun. It's revealing how Mars lost much of its atmosphere over time, turning from a potentially habitable planet into the dry, dusty world we see today. Don't forget about Odyssey, NASA's longest-running Mars spacecraft, which has been orbiting the red planet since 2001. Its work is groundbreaking, mapping chemical elements, studying radiation levels, and even finding vast amounts of water ice in the polar regions. Talk about a trailblazer. The Mars Reconnaissance Orbiter is another powerhouse. Active since 2005, it does double duty as a science observer and a communication relay for other missions. MRO has a knack for scouting future landing sites, making sure every mission that follows is even more successful. And who could overlook the legendary rovers? The Opportunity rover, initially a 90-day mission in 2003, ended up exploring Mars for 15 years. It investigated craters, studied meteorites, and taught us how to survive those infamous Martian dust storms. The star of today's Mars exploration is the Curiosity rover, which landed in 2012. Armed with lasers, drills, and cameras, it's been studying Mars's geology and climate, proving that water once flowed there. Curiosity even detected organic molecules and seasonal methane spikes, potential hints of life. Each mission adds a new layer to our understanding of Mars, bringing us closer to answering one of humanity's biggest questions. Are we alone in the universe? Should we call Mars home? Not everyone's on board with the idea of packing up and heading to Mars. Critics argue it's a monumental gamble, too expensive, too risky, and frankly, too inhospitable. From the challenges of travelling through space to the health risks for astronauts and the tough job of surviving on Mars' barren landscape, the concerns are daunting. And that's before we even consider how we'd maintain a colony or handle emergencies millions of miles from Earth. Still, for all the hurdles, there's a growing buzz in the scientific community about cracking these puzzles. Cutting-edge research and bold missions aim to figure out if Mars could be humanity's next home, or if it's a dream best left to science fiction. 2030 to 2040, the first footsteps on Mars. By the 2030s, human footprints grace the surface of Mars. NASA and SpaceX lead the charge, deploying astronauts, engineers, and cutting-edge robots. The cost of these missions reaches hundreds of billions of dollars, but the stakes are astronomical. Early settlers rely on habitats constructed by autonomous robots using 3D printed materials, creating protective structures resilient to harsh Martian conditions like intense radiation and freezing temperatures. Life on Mars begins underground. Subterranean farms grow genetically engineered crops, providing a sustainable food supply. Meals consist of lab-grown meats, algae-based proteins, and even Earth-imported treats, though these luxuries come at a premium. Early colonists battle isolation, limited resources, and the psychological toll of living millions of miles from Earth. But their determination lays the groundwork for future generations. 2040 to 2060, laying the foundation. By the 2040s, Mars becomes home to dozens of permanent settlers, supported by robots with quantum computing capabilities. These machines handle complex tasks, from mining Martian regolith for construction materials to maintaining biodomes filled with oxygen-producing plants. A network of biodomes expands, creating controlled environments for food production, oxygen generation, and leisure activities. Advances in energy technology power the Martian outposts. Solar panels and nuclear fusion reactors supply energy, while Martian dust storms pose challenges for solar efficiency. The introduction of artificial trees and turbines aids in converting carbon dioxide into oxygen, slowly improving air quality. This era witnesses a groundbreaking discovery: microbial life beneath the Martian surface. These microorganisms, adapted to extreme conditions, challenge our understanding of life and spark debates about preserving Mars's native ecosystems amidst human expansion. 2060 to 2100, Transformative Technologies. Medical advancements revolutionize Martian life by the 2060s. 3D bioprinters produce organs, dramatically reducing the mortality rate of settlers. Nanotechnology repairs damaged cells, and genetic engineering enhances human resilience to Mars' environment. Diseases like cancer are eradicated, and the average lifespan begins to extend significantly. Terraforming accelerates with the introduction of orbital solar reflectors that melt polar ice caps, releasing water vapor and carbon dioxide. Genetically modified bacteria and algae are deployed to kickstart an oxygen-producing biosphere. The dream of a breathable Martian atmosphere becomes tangible. Transportation also takes a leap forward. Nuclear fusion and antimatter propulsion reduce travel times between Earth and Mars to mere weeks, making interplanetary commerce feasible. Earth exports luxury goods to Mars, including fashion, art, and technology, while Mars exports rare minerals and scientific innovations. 2100 to 2200, a thriving Martian society. By 2100, Mars boasts a population of hundreds of thousands. Underground cities expand into sprawling metropolises, blending advanced architecture with Martian aesthetics. Robots equipped with artificial intelligence manage most aspects of daily life, from construction to agriculture. Superconducting rings, strategically placed around Mars' equator, generate a planetary magnetic field, shielding the surface from solar radiation and aiding atmospheric retention. Interplanetary travel becomes routine. Spaceports on Mars bustle with activity, connecting the red planet to Earth, the asteroid belt, and the moons of Jupiter and Saturn. Mars emerges as a hub for asteroid mining, its economy booming with the influx of precious metals and resources. Terraforming reaches new heights as rivers, lakes, and forests begin to dot the Martian landscape. The equator hosts tropical ecosystems, while temperate forests thrive in mid-latitude regions. The introduction of insects like bees and earthworms transforms soil fertility, enabling larger-scale agriculture. Small animals, some genetically engineered and others imported from Earth, form a diverse food web. 2200 to 2300, Mars gains independence. The 2020s mark a turning point. Mars declares independence from Earth, forming its own governing systems. City-states emerge, each with unique cultures and governance models, yet they collaborate on shared resources and terraforming initiatives. This era sees the establishment of the first interplanetary federation, uniting Mars, Earth, and other colonies across the solar system. Martian society becomes culturally distinct. The first generation of Martian-born humans thrives, developing traditions and identities unique to their home planet. Celebrations like Terraforming Day commemorate humanity's achievements while Martian arts and literature flourish. The terraforming process achieves its most ambitious goals. A breathable atmosphere allows residents to walk outdoors without protective gear. The skies, once a hazy pink, turn a deep blue, though dust storms still occasionally colour the horizon in shades of red. Vast oceans cover nearly half the planet, dotted with islands that become tourist hotspots. Scuba diving in Martian waters becomes a sought-after activity. 2300 to 2500, a global ecosystem on Mars. Mars is now a thriving, self-sustaining world with billions of inhabitants. Its forests, rivers and oceans teem with life, both native and imported. Advanced genetic engineering introduces new species that adapt to Mars' unique conditions, creating an intricate and balanced ecosystem. Cities on Mars rival Earth's iconic metropolises. Skyscrapers of futuristic design dominate the skyline, while flying vehicles navigate the skies. Holodeck chambers, immersive virtual reality pods, allow residents to experience life on other celestial bodies, from Earth's beaches to Titan's icy landscapes. The success of Mars inspires humanity to push further into the cosmos. Colonies on Phobos, Deimos, Europa, and Titan flourish, while massive O'Neill cylinders orbit the asteroid belt, offering habitats for millions. Mars becomes the economic and cultural epicenter of the solar system, its innovations driving humanity's expansion. 2500 to 3000, Mars and beyond. The 2000s and 50s see the integration of super-intelligent AIs with Mars ecosystems. These entities manage resources, monitor environmental health, and even participate in governance. The relationship between humans and AIs evolves, with some Martians opting to merge their consciousness with machines, blurring the line between biology and technology. Terraforming efforts culminate in the complete transformation of Mars. Its climate stabilizes, mirroring Earth's. Tropical rainforests near the equator teem with biodiversity, while expansive grasslands and temperate forests cover the mid-latitudes. Oceans support marine life, and fishing industries emerge as a vital part of the Martian economy. Mars's cultural identity matures, celebrated through massive art installations visible from space. These creations symbolize humanity's unity and creativity, blending Martian and earthly influences. Martian arts, music, and cuisine become highly sought after across the solar system. By the year 3000, Mars stands as a beacon of human achievement. Its journey from a barren wasteland to a vibrant, thriving world is a testament to ingenuity, resilience, and the unyielding desire to explore. Humanity's success on Mars serves as a blueprint for colonizing other planets and even venturing beyond the solar system. The future of Mars isn't just about survival, it's about thriving. What excites you most about Mars's transformation? Is it the terraforming, the futuristic cities, or the idea of interplanetary travel? Share your thoughts in the comments below, and if you're inspired by this vision of the future, don't forget to like, subscribe, and join us on this incredible journey through the cosmos. Let's shape the future together.